let's talk about a very fascinating, very important, very real phenomenon that could happen here with random trends. That could happen in stationary and non-stationary time series models. So let's take a look at it. So again, looking at it through an example, we'll load up TSWGE, but first we'll look at it from this stationary model with V1 equals 0.9. And again, verifying that we've got a root outside the unit circle, just reinforcing that. We've got a variance of the AT term of 1. We're only going to generate a series of 30 right now. And we know that there is no trend. We know that this is a stationary model that will be, in this case, attracted to a mean of 0. If it goes up, it'll come down eventually. If it goes down, it'll come up eventually. There's no deterministic positive or negative trend in this data. However, if I generate a series of 30 with positive correlation of 0.99, then we'll see that if this was a series that we just have, if we went and took 30 observations from some process, sales or some scientific data, we might, if that's all we had, we might look at this and say, wow, that's some evidence of positive trend there. But we should, through our study here of time series, note that if this has positive autocorrelation, this is usual. That I might not be surprised about that, and that if I actually look at a few more, even if I go out to 100, if I look at another 70 observations, that it could very easily turn around. This is what we just observed, but this was just a false trend that could easily happen with some significant positive autocorrelation, and it eventually comes back down. And as we know, it'll come back up and down many times because it's a stationary model. It's a stationary process. Again, if I do 1,000 here, it will. This is what we saw. It went up and then came down, and then it went way up, but then it came way down. So we got to think about the process that's generating the data that we have, and that will that'll play a big part in how we choose the model that we'll choose to model that process. Okay, so one thing that I want to look at also, that's for a 0.99. We could probably stop there, but let's just go ahead and generate gen.arima. Let's just do this, arma.wge. Let's say 100 comma phi equals 0.99. And I'm not even going to put a seed on this. I'm going to encourage you to explore these on your own. But how easy could it be that if I had observations of 100, if I had 100 observations, how plausible is it that I would get one that looked like it just randomly had positive or negative trend? This one would not be, right? It kind of goes down and back up. And 100 is a significant number of observations. So I'm not sure what we'll find here, but let's just see what we've got. That one might be a little more evidence of positive trend. But let's see if we can, how about that one, right? At least until 90, that would have been, some people might look at that and say there's definitely positive trend in there, but they'd be wrong because eventually this one will turn back around. We can look at a couple more here, right? Just go through. 100 is a lot of observations. There's another one that kind of makes it up to about 90. So that's another way, kind of through simulation, that you could kind of get an idea of how many samples you might need to see if it's plausible that this is pretty significant stationary autocorrelation at 0.99. But even at that, at 100, that looks like a false trend there. We know that it eventually comes back down. Now let's look at what happens when we increase that to an ARIMA model. D this time, instead of a phi of 0.99, we have a D equals 1, which would effectively be the same as making phi equal to 1, but that'll throw an error in gen.arma, and D equals 1 is how we do it in ARIMA. So there it is. After 100, that looks like pretty significant negative, false. That's a random trend, but something that could very easily happen. It has no mean, but it'll eventually turn around and go up and down. There's no deterministic trend that's drawing that thing down. It could easily go up, down, and all around. So that one's not a lot of evidence, but there's one right there. Not too hard to get one that has random trend. And again, if I just do this, I just can't resist. If I eventually find one here, let's say that one, right? That looks like some evidence of negative trend. and I did it with SN equals 1, so I'll be able to generate the series again. But let's see what would happen if we could just get another 200 observations. Does that negative trend continue? Well, maybe, it went down, it kind of leveled off, but let's see if we can really, again, I'm hoping you play around with this on your own, but kind of flattens out there. Let's see I'm just curious to see what happens with this, right? And this is just playing around with TSWG. Yes, and eventually it went back up. So somebody might have really thought if they could only afford 100 observations that they're really looking at negative trend, make some business decision based on that, when really it was just because today was related to yesterday quite a bit in a non-stationary fashion with the roots on the unit circle with a phi 1, in this case, of 1, which would be non-stationary wandering. So long story short, beware that random trends exist. Beware before you try to fit a signal plus noise model with some sort of deterministic trend in there. We might just be looking at a false or a random trend. So great job. Keep up the good work.